Hi, I'm Gary Mack, host of SciEngiMathePloration. I'm sitting inside the new Chevy Volt. If you want to learn something about the future of automotive transportation, be sure to watch SciEngiMathePloration on this public access station. Hi, and welcome to SciEngiMathePloration. I'm Gary Mack.
I'm Anna Mark.
And we're here to find out about automotive engineering. We're at the Walter P. Chrysler Museum just north of Detroit, and there's a lot of exciting things here and a lot of information about automobiles and automobile engineering and a whole history of the Detroit area. Our special guest today is Jim Berry. Jim, thanks for having us.
Hi, welcome aboard.
Great. Now, here at the museum, there's some information about automotive history and automotive engineering. What are we going to see?
Well, Chrysler Corporation has been known for engineering throughout its history. There have been some key people that have provided some great innovation and ideas. I think it's the model that the company continues to use today.
Great, and there's some exhibits we can look at and find out exactly what went on.
Let's see some.
All right, let's go.
Yeah. All right, so Mr. Berry, will you tell us a little bit about Walter P. Chrysler?
Well, let's meet Walter Chrysler. Walter was an American up from his bootstrap story. He started out in a railroad family, and he learned engineering literally on the machine in the railroad shops. Worked his way all the way up to running a whole locomotive works factory that had 10,000 workers. So he was involved in transportation design and manufacturing from the very start. His revelation was when he saw his first automobile, he thought this was the game changer, that no longer were we going to ride around in trains, but we could ride from door to door and not have to share the seats with many other people. So he bought a locomobile in 1908, took it apart dozens of times before he even learned how to drive it, and he was absolutely convinced that this was the technology of the future.
Wow. All right, well, let's keep moving, shall we?
Okay.
So behind us now is Mr. Chrysler's first automobile, is that correct?
Well, this is the first automobile to bear his name. Remember, he was at Buick working for General Motors. He didn't get along with his boss. He retired at age 45, a millionaire, got under his wife's feet around the house, and he went back to work rescuing faltering car companies right after World War I. He met three engineers in one of these companies, Owen Skelton, Fred Setter, and Carl Breer. And these guys were college-educated engineers for the first time in the corporate history. And they were designing a revolutionary new car. Walter was sort of the promoter and made it happen. That car had a couple of false starts, but wound up being the 1924 Chrysler 70 model. Wow. 70 stands for 70 miles an hour.
Pretty neat. So what is so unique about this particular car?
Well, you got to remember, cars in the mid-1920s, think of silent movies. They were bumpy, they shook, they weren't very fast, they weren't weatherproof, and here was a car that could drive all day at 70 miles an hour and not tire the driver out. It had innovative features like four-wheel brakes. Imagine not having four-wheel brakes today. Well, and those brakes came from the aircraft industry. The Lockheed Company, who makes airplanes, developed the hydraulic brakes for that. It had an engine that put out much more horsepower than engines before. It just had modern improvements, the things that we take for granted in cars. He pioneered in 1924. The car was an immediate success. Launched the company, and pretty soon, within 5 years, they had bought Dodge Brothers, the Dodge brand. They had come out with two new cars, the Plymouth and the DeSoto, and the Imperial, and became one of the big three in very, very short order.
You know, contrary to many people's views on engineering, it really incorporates a lot of creativity rather than just math and science. How did creativity play a role in Chrysler and these vehicles?
Well, we talked about the three musketeers, the three engineers that Walter employed to be in his first car. And these guys were just curious about everything. And here's an example. Fred Zetter, one of the head engineers there, had to go in the hospital, the Mayo Clinic, the famous Mayo Clinic, because he had stomach problems. And his treatment wasn't very extensive, and he had a lot of time on his hand. So he bugged the Mayo brothers to let him follow them around the hospital and watch the operations. And he's watching an open heart surgery where he can see the heart pumping away in this chest, and he's looking at it from an engineer's point of view. How does that heart that's pumping away not shake the body back and forth? And he came to the conclusion that the blood vessels and the arteries coming in there sort of acted like a hammock, and it suspended the heart so it could beat away, but the transmission of vibration didn't happen throughout the body. And he gets back to Chrysler, all cured up from his ulcers. He starts thinking about, well, how do I keep an engine which wants to rock and shake as it turns through its motions from shaking the whole car back and forth? Because in the early days, they were simply bolted on, and if the engine shook, you shook in the driver's seat. His idea was to put some rubber cushions under the connecting points and hang it like on a hammock. And he tried various combinations, and he got it so the engine vibration would be self-dampening. It would not transmit those vibrations on into the driver. That car became the Plymouth, and they called it floating power. All of our cars have this innovation today. It makes it a smooth ride. We forget the engine's even running.
Pretty cool. So we've heard about how Chrysler has been a step above the rest in the engineering aspect, the under the hood type of stuff. But I look around and I see these amazing looking cars. The aesthetics are wonderful. What is this all about? How does creativity, you know?
There's an old saying, form follows function, and a lot of what Chrysler engineers try to do is make the ride experience more comfortable, more pleasurable for the occupant of the car, the driver. They began working immediately after the success of their initial cars on another game-changing car. They called it the Airflow. It was a car that was designed in a wind tunnel. Carl Breer noticed that airplanes and geese all had a shape that seemed to cut through the wind better, so he got one of the Wright brothers to build a wind tunnel to test out models in. And they came up with a car that was streamlined. And one of the interesting things they found out was conventional cars had better aerodynamics going backwards in the wind tunnel than the front, because the front of the car was just a chopped off radiator, chopped off straight up and down windshield, and the back was more curved. So their radical car, the Airflow in 1934, didn't look like anything else, and the public didn't respond to it. It didn't look like $1 million that they were used to. It looked very futuristic and kind of odd. They struggled with that car, but it was often copied later on and became the basis of all the aerodynamics that are built into cars today.
All right, Mr. Berry, will you tell us a little bit about this scene behind us?
Well, Chrysler was putting out some very interesting cars in the 1930s, and up comes the conflict of World War II. The smartest guys on the block get put to work on solving problems for the military, transportation in particular. And one of the companies that eventually became part of Chrysler was a company called Willys Overland. They got the contract to produce this quarter-ton all-wheel drive scout vehicle called General Purpose, and later became nicknamed the Jeep. The Jeep now is celebrating 60-some years of being a popular American icon. But it was solving a problem and solving it on a large scale. 250,000 Jeeps were built during World War II. They went all over the world. They were recognized for being able to do what they needed to do, and became very useful after World War II. And it's kind of an example of how the car companies pulled it together and supported the guys out on the front.
Cool.
So let's go look at some other stuff.
Yeah.
Let's find out where Gary is.
Yeah. Where did he go? Oh, there's Gary.
Yeah.
Geez, what are you looking at?
Well, I'm looking at this big engine, or more than one engine, right, Jim?
It's 5 engines, and it's for a tank, battle tank. The problem in World War II was you had to build some new armament, some new weapons that would outperform the enemies. And it would take too long to design something from scratch. So they took 5 car engines, 6-cylinder engines. They put them in a radial pattern around one crankshaft. So those pistons are turning one crank. and then they had to synchronize them all for their spark plugs and get the exhaust out and the cooling in to produce a 30-cylinder engine. These engines fought in North Africa. They gave good service. The British swore by them as being very dependable, and they were able to turn this around and get it into a tank and out into the battlefield in a matter of months, not years. How would you like to have that in your car?
Well, I wouldn't want to do the tune-up. That would be the problem.
I think
30 cylinders.
What you looking at now, Gary?
Well, this is steering, Anna. Power steering.
And Gary was looking at the good old days here when nobody helped you steer the car. You mechanically turned the wheel, which was pretty heavy steering there, and through a series of gears and levers and that, it changed the direction of the wheels. Power steering means you put a motor that hydraulically changes the position of the wheels, and as Gary's showing, you can do it with one finger.
Wow.
So you can come to the museum here and see the cars that your grandfather talked about, or your dad or your mom talked about, and sort of relive those stories from the family in front of the real deal here. The age of fins and chrome, the downsizing of cars to cope with the gas and oil crisis. There's a lot of interesting change that we've all lived through here on the second floor of the museum.
Wait a minute. I used to drive that one over there. Well, this has been a fascinating tour here at the Walter P. Chrysler Museum, just north of Detroit on the grounds of the Chrysler headquarters. Fascinating trades of all of the kind of different things we've seen here, all the different kinds of technology. Jim, thank you very much.
Oh, you're welcome. We've come full circle, and we're looking at cars, the future now, and based on that heritage of the past.
Well, it certainly has been an interesting experience. I've learned a lot. How about you, Anna?
I've learned so much just here in this one little segment.
And we've turned you into a car person?
Definitely.
All
I'm going
right.
to go get my hot rod and go drive right now.
Great. Thanks a lot, Jim.
You're welcome.
Hi, I'm here with Craig Garnett, who's the production and engineering manager here at the Ford Motor Company Michigan truck plant. Craig, thanks for having us.
Thank you for coming.
Well, I see we're here in the middle of the plant. It's a quiet time right now, but this is a center of activity. What goes on here?
Well, that really is the future and methodology of modern manufacturing, is combining people with robots. People take on the process that robots cannot handle, and you try and automate as much as possible.
So there are a number of robots working. Now, people are still required. People have to program the robots, right?
Oh, absolutely. We have a whole full engineering staff, a full maintenance staff. We still have a supervision staff. And the hourly workforce, still there's many things that robots cannot do that we rely upon the hourly workforce to do.
Now, you manage the folks that manage the robots then?
Of course, and also the whole hourly workforce. I'm the production and engineering manager, so I have a staff of 7 salary heads and then 106 hourly heads beneath that.
Now, robots aren't what we see on science fiction. They don't have heads and talk and roll around. These are fixed in place. They do a specific task. But still, they're very powerful and have to be programmed carefully. Can you tell me about that?
It is a lengthy process, but basically these robots, you're absolutely right, do not look like science fiction. They're built for robustness, and they're built for millions of cycles to do it over and over again without breaking down. They do require some maintenance, but other than that, modern robot technology is pretty impressive.
All right, that's great. Well, let's take a look and see what's happening with some of these cells.
Okay, this is framing segment 1, the beginning of the framing process. In the distance there, up above, we see a conveyor bringing underbodies, which is nothing more than a flat floor pan and a front end to it, to framing. There it heads down the elevator and comes down to the process. As you see it rolling towards us, several different parts are being added to it to be welded on. You'll see the front end, the body sides from the conveyors on either side being grabbed by the robots, twisted down, and put in the correct location. And the robots are also adding some roof bows, so you basically have a loose unit that'll roll into a framing buck. This operator here is adding more roof bows specific to its particular type of unit, whether or not the unit is long or short, or has a has a moonroof or not. And that will then go to the final process where it all gets framed together. The loosely tabbed together units with the front end, the body sides, and the roof bows are now rolling forward to the second half of framing segment 1, where they're going into the framing buck. The framing buck will take this loose unit, grab it with pins, clamps, and nets, holding everything in the correct location, and then welds it together with 12 robots all at once. And this is essentially the beginning of a finished unit.
Hey, it's been a great visit to the Michigan truck plant. Many thanks to Ford Motor Company. This Lincoln Navigator is the kind of vehicle we just watched being built. Pretty amazing, huh? All that automation and all the things that go into it. Thanks for joining us. Hey, we're at the General Motors Proving Grounds in Milford, Michigan. I'm in the Charge Integration Lab with Andrew Farah, and we're here with the new Chevy Volt. Andrew, this is the car of the future, isn't it?
Yes, it is. The Chevy Volt is a whole new way of looking at transportation, and I'm happy to be a part of this program.
Well, what's different about it? I mean, I've got the hood open here. It looks like a car to me.
Well, if you kind of look under the hood, you see it's got a lot of things you wouldn't expect to find, but it has a lot of the things you do expect to find, like an engine. But unlike a lot of vehicles, the Chevy Volt is actually two almost completely separate vehicles put together. You take all of the characteristics and advantages of an electric vehicle that can go up to 40 miles without burning any gasoline at all, and then you bring it together with the typical components of a gasoline-powered engine and vehicle. And so if you choose to drive more than 40 miles, you can seamlessly go into running the engine and burning fuel, so the customer never really knows that they've had any of these transitions at all. And part of the job here of engineering is to make sure that is seamless to the customer, that they get all the advantages of an electric vehicle with none of the disadvantages, but can still drive hundreds of miles on, say, weekend trips or daily trips that might be more than 40 miles.
Going on vacation. So this is the best of both worlds. We've been in the car business for 100 years or more, and I think cars actually started with electric cars and steam cars and things like that, and now we're back to electric cars.
They did. It's kind of been an evolution. Electric vehicles were actually very popular at the turn of the last century, not the most recent one. And the idea of coming back to electric was something that in the 90s had a big following, and then it kind of died out for a while, although here at General Motors we continued to work on refining that, which is one of the reasons we can get the Volt to market so quickly.
Right now, we'll be able to drive this car and buy this car in the very near future, right?
Yeah, we're shooting for the end of 2010, and we're on track to get there.
Well, I've understood that batteries are really a thing of the future, and that if young people wanted to study certain kinds of things, they would want to look into electrical engineering and battery technology, things like that. What would you say to a young person who wanted to work on a car like this?
Well, two things. Number one, batteries, very important, the actual chemistry of the batteries and developing the basic cells of the battery. But then on top of that sits the whole idea of controls, control systems, and then the hardware and software to put those together, mostly computer hardware and software, not the PC type things, but what we call embedded systems. You program them similarly, but they don't have a screen and a keyboard per se. They're in there monitoring different things, temperature, voltage, current, and making decisions on how to drive and how to charge and discharge the battery. So I'd say those would be the two areas when it comes to this kind of technology that I think will be excellent career opportunities for the future.
That's great. Now, one last question. Is this a fun car to drive?
Oh, yeah. It's very, very much a fun car to drive, because when you get in and you start out in electric vehicle mode, the silence is what it is that gets you, and you say to yourself, oh, this is so wonderful. But it also presents some challenges, which is you have to make other things as quiet too. And that's another area of work, what we call noise and vibration work, to make sure that the vehicle is delivering that quiet performance, and that's more of a mechanical area. And again, another great career choice for young people.
Right, and I understand too that the electric power plant is going to be available in a range of General Motors vehicles. It won't just be a Volt, you'll be able to get that power plant in other cars as well.
Yes, the whole system that we're using here to create what we call extended range electric vehicles, our plan is to bring that into other vehicles in the future as well.
Well, that'll be great. I can't wait to have one in my driveway.
We'll try to get one for you.
All right, good.
Hey, Gary.
Hey, Anna, how are you today?
Good, how are you?
Good.
What are you working on?
Well, you know, today's show is all about the Motor City Heritage area that we live in and all the different kinds of automotive research that goes on in our area. Some of the most important research that's been done over time is to make cars safer. You know, today's cars have airbags in them and seat belts and padded dashboards and all different kinds of things to make them safe. Well, a lot of those safety developments were invented as a result of crash testing, where you'd actually crash a car into a wall and then try to make it safer. So I thought we could try an experiment like that.
Okay.
We're going to take a car, we're going to run it right down a ramp and right into a brick wall.
Uh-oh.
You know what happens then?
Splat.
Splat, exactly. Well, here's my setup over here. I've made a little ramp here out of just a piece of wood and a couple of clamps, and you see down there I have a brick wall for us to run into. For test vehicles here, I got these little cars at the dollar store. I took the inside of them out so we could use them. And let's try one to see what happens here. If we run this car down the ramp and into the wall, splat.
Splat.
Comes to a pretty abrupt stop, doesn't it?
It does.
Well, what do you think would happen then if we put a passenger, in this case an egg, inside the car and ran it into that wall?
Major splat.
Well, shall we try it?
Sure.
All right, here we go. Let's see. Ready?
Yep. Splat.
Quite a mess. Now, another experiment we could try then would be to take the egg, but put a seat belt on the egg to sort of hold it in place. What do you think will happen then?
Well, it might work as a real seat belt, holding the egg in and protecting it.
Well, we would hope, wouldn't we?
Hopefully.
All
yeah.
right, let's give it a try. You go down to the end of the ramp.
All right.
I'll put this seat belt on the egg here very carefully, making sure it's in place. There we are. Are you ready?
Yep. Oh, look at that. The egg didn't break.
Well, so I guess we could say that seat belts really do work, huh?
I guess so.
All right. Now here's another experiment we could try. We could try to protect the egg somehow. Now I have here this kind of foam stuff. Have you ever seen this stuff?
Yeah, with like packaging and stuff like
Right,
that.
exactly. Well, wonder what would happen if we took an egg and we put it inside the foam and tried to protect it from the crash with the foam. What do you think will happen?
I don't know, Gary.
Want to try it?
Yeah.
All right, let's see what happens. We'll put it in the car and we'll send it down the ramp, right?
All right.
Here it comes.
How's it looking there?
Well,
Oh.
doesn't look good.
Oh, no.
I don't think that was enough protection.
I guess not.
Okay? I got another idea.
All right.
Well, here's what I thought we should try next. Now, here I have a piece of bubble wrap. And unlike the foam, this has a little more thickness to it.
Okay.
I think all those little air pockets
Yeah.
in there. I think this might actually work. So I'm going to take the egg. I'm going to wrap it up in the bubble wrap here.
All right.
And then we're going to put it in the car. And one more time.
All
See
right.
what happens.
All right, let's see how this one did. Looks pretty good.
The egg is saved.
All right. Good work, Bubble Wrap. Well, you know, Gary, we're dealing with eggs here.
Yeah.
How strong actually is an eggshell?
Well, you know, you might be surprised about eggshells. As a matter of fact, I have another experiment I could show you that tests the strength of eggshells.
all
Want to see
right.
it?
Yeah.
Okay.
So, Gary, how are we going to test the strength of eggshells?
Well, here's a way I thought up that we could try this. And here's what I did. I took a couple of eggs and cut the eggshells in half and, poured out the insides. So we have these eggshells here. And I'm going to take the 4 eggshells.
Okay.
And I'm going to put this little platform right on top of them there, just so we have something to do it.
Okay.
Then what I thought we could do is just see how much weight it would hold.
Okay.
All right, well, I have some cans from the pantry to put on here, and as long as I put them on carefully.
Wow. They look pretty good so far.
So far, yeah, I'm getting a little nervous about
Yeah.
just even balancing them up there.
The Leaning Tower of Tomato Paste.
Right there. Now, would you think that those eggshells would hold even that much
Even
weight?
that much, I would never have guessed.
And you're probably wondering how much weight that is.
Yeah.
Well, we have a scale right here. Let's bring it over here and see how much weight we had on those eggs right there. It says it was over 4 pounds.
Wow.
4 pounds, 4 ounces just on those eggshells right there.
Wow.
So eggshells actually are pretty strong. Their strength actually comes from their shape. The fact that they're dome-shaped like that spreads the weight out evenly around the base where it's
okay.
cut. So that's a really strong structure
Wow.
in nature. So see, there's lots of experiments you could do. You could try the crashing the eggs. Of course, if you're going to try that at home, you want to be sure that mom or dad says
Yep.
it's okay. 'Cause
Plenty
it
of paper towel.
Plenty of
around.
paper towels. It is a little messy. And this is kind of interesting, too. Let me show you how I set up the eggshells
Okay.
for this, okay? All right, here's how you make the eggshells prepare for that. What you do is you take an egg, regular, normal, raw egg, and you need a piece of masking tape. And you put it right around the middle of the egg here. That can be the hard part, is finding the middle of the egg. But you leave a little gap where the two pieces of the masking tape come together like that.
Okay.
Then you take a pair of fingernail scissors, make a real small hole in there, like that.
Okay.
And then you start to cut right down through the middle of the tape. And that holds the eggshell from shattering while you're actually cutting it in half. Now when you get to a certain point, this is going to get to be a little messy. So you have to have something. Hand me that trash can.
Yep.
You have to have something just like that.
All right.
Then if you rinse those two sides out, you have 1/2 the number of eggs you need for that experiment, just like
cool.
that. Well, there you have it. Crash testing with eggs, and eggs are surprisingly strong. Some interesting experiments today.
Yeah.
Well, listen, we have to go, so we should thank some of the people who helped us
Yeah.
with this show.
Thanks to the Walter P. Chrysler Museum out in Auburn Hills, Michigan.
Right, and then our friends at the Ford Motor Company Michigan truck plant, and then the engineers we met at General Motors Proving Grounds in Milford, Michigan. It's been a great show, all of it about the Motor City Heritage area right here in Southeast Michigan.
Thanks for watching SciEngiMathePloration.
See you again.
Bye.